Oh, the music stops. That's the key. Ah,
yeah,
okay.
That must be it.
We wondered how it worked. Okay. Do you want to start? Okay. Oh, I'll start. Welcome. What day is it? Thursday. Yeah, got punch drunk. Welcome to Are You Ready for Cloud Native Java? Anybody here ready for Cloud Native Java?
Excellent.
Good. We're going to quiz you. We're going to quiz you. Okay. Well, let's do the... Did you do that?
I haven't done. Do you want that?
Oh, no. I'll just press buttons. Go next one then, please. Thank you. So, two old men from, well, oldish men from IBM. I'm this one, Steve Poole. I work for IBM. I'm a developer advocate, and that means I get to come up and talk to you about really what I want, Java stuff and things like that. My background is all VMs, and so I'm going to talk VM to you.
And I'm Graham Charters. I work in the Liberty development team, and I also tend to do advocacy, so come out to conferences and things like that, user groups and so on, and talk about things like Cloud Native Java and MicroProfile and stuff like that.
Yeah, okay. And we're going to try and confuse this camera by being far apart. Shall we do that? Yeah. Okay. Right.
So before we start, so we as you've said, as we've said, we work for IBM, which is quite a large company. I'm sure some of you work for quite big companies or have maybe worked for big companies in the past, and big companies have this habit of when they want to teach you about something, so they need you to understand what GDPR is, for example, or need you to understand about secure engineering and so on, they create education for you. And those education things tend to take you through a process of, they teach you a little bit and they'll have a little bit of quiz and they carry on teaching a bit, another quiz, and then there's some final questions at the end and then you get a certification. So we thought it might be fun. Now, some people's fun is another person's torture, but we thought it'd be fun, at least fun for us maybe, to actually structure the talk in that style. So we're going to have a little bit of education, or we will have questions. So you know how sometimes in talks people say, pay attention because there'll be questions at the end?
Yeah.
Well, it's actually true.
Yeah.
Okay.
And the winner will get the T-shirt that I wore yesterday.
Ooh.
Okay, yeah.
And if you fail the certification, then we start the talk again.
Yeah. Okay. Stop doing that. I'm going to press buttons. Okay. So, first quiz. You've been deploying Java applications for years and you want to move to a cloud-native approach. Of course you do. Do you? A, decide cloud-native is so different that you should just throw everything out. Let's move to Python and Node and stuff like that because it's so different. Who votes for A? Who plans to do cloud native by losing all their Java stuff? Ooh, no hands. Okay. How about B? Okay. You decide that cloud native is a storm in a teacup and you're going to ignore it. Who plans to ignore cloud native? Okay, one. Okay, maybe one. Okay, cool. You'd be surprised. Okay. Or C. Should you understand how modern Java runtimes let you reuse and extend what you have in order to create new cloud-native applications? Who votes for C? Okay.
Yay.
If none of you voted for neither A, B, or C, it's probably time to go.
Yeah, they're doing well so far.
They're doing really well. Okay. Okay. So, what does this really mean? We talk about cloud-native. You have to look about it. What's this little back thing? Is that this fly?
Yeah.
Okay. Okay. It's not my presentation. Okay.
We've got animated slides.
Animated slides. Yeah. Ah, excellent. Okay. Let's see. Right. So, cloud. Cloud is different. So I'm going to talk a little bit about why cloud is different, why it's special. Okay. What does cloud promise you? What does it promise your organization? What does it promise you as developers? Okay, so lots of words, but if you think about it, it's quite cool. It's this virtual thing. I can buy resource as much as I want, infinitely scalable, always there, and I don't have to put capital expense into it. I can just borrow somebody else's machine, pay them some money, and I can use it. And when I stop using it, I can throw it away. I can stop paying money. Okay? Take your code, run your lovely code, and run it on somebody else's machine, pay for what you used, and then stop and do it often and as much as you want. You know, that's cloud. That's pretty good, isn't it? Compute on demand. It's what we've always wanted. We have worked for years as an industry to give you compute on demand. Hey, it is fantastic. It is the best thing, I know, ever. But it brings with it some new factors. And this is where it's different and where it's special. So, cloud computing. Compute equals money. So you think about this. When you deploy to cloud, something new is happening here. Your accountants are paying money in a different way. Okay, and they're beginning to make the connection between what you use and what it costs. Okay, that's always been there, but with this new relationship, suddenly with cloud, suddenly it's much more obvious. You know, you go to Amazon and you buy, which size VM should I buy? How long should I buy it for? Oh, money costs, right? Suddenly, money and computing are now much closer together in the heads of the people who pay for it, okay? And as you can imagine, once you start doing that, people start going, hang on a minute, why are you spending this much money? Okay? So cloud starts to take us from compute equals money. Okay, so what that really means is money equals gigabytes per hour. That is the biggest equation that we live by. It's not the only equation, but it's the one that most of us live by is I buy memory, okay, by the hour. And it costs money. So as a Java developer, this is your new life. Okay, it's not a variable. Okay, so what does that mean? It means that if you decide you're going to increase the heap size of your Java because you need to, because you've just put a feature in and now it's going to cost more memory, your accountant may say, what do you mean you want to increase the XMX size? That costs me money. Prove that you're going to make that money back for me. All right? And that's what's happening. Okay. So let's turn that into some pictures so we can sort of talk in a little bit better way. So you have your application, and it has a demand. It isn't demand that's static. It always comes up and down, and maybe you can predict it. Maybe it's Friday afternoons, there's nothing, and Monday mornings it's enormous, but you have some demand. And you have time, okay? So if you were doing this locally, on-prem, and you say, I'm going to deal with this, what do? You build one big server, okay? Maybe it's a cluster, but it doesn't matter. It's an enormous amount of capacity, and it's fixed. It has a limit. And the limit that you set yourself is your prediction of what your peak workload is going to be, plus a bit more. Okay? That's what you will do. And that's fine, right? You've bought a machine, and you're going to have it for 5 years or whatever, and then you'll buy a bigger one. But that's your process. You size that way. Okay. So if you take that approach, one big machine, that sort of workload pattern, and you take it and you push it in the cloud, suddenly all the capacity that you've bought that's not being used because the load is less is money wasted. And your accountant goes, can we do anything about that? So as an industry, we went, yeah, we can do something about that. How about we broke our application not into one big monolith, one big solution, we break it into smaller parts. Smaller parts can fit under the curve a little bit better. And then if you go even more, you get even better fitting. What's this called? This is microservices. This is the reason, the primary reason that we do microservices. Microservices lets us deal with the scaling issues and the economic issues that cloud give us. Right? We can react to the workload easier with this architecture. And it also means that when we're not using them, when the workload is reduced, it's easier to give the money back. It's easier to reduce your heap sizes because you just kill the services. Smaller computer units are better, okay? However, we have a challenge. So if you take any one of those little blue boxes and you think about what the performance profile looks like, it looks a little bit like this. Over time, Java applications tend to, because of the way that VMs work, take time to get to the point. So the red line is maximum throughput, from nothing to full throughput. Okay, it takes time to get there. We all know there's JIT's got to go in there, it's got a profiling, all those sorts of things. And at the same time, you're using memory, and you tend to have memory with a big peak at the end, which gets caught back. Okay, so you have to use all this memory to get to the point where your application is running steadily, and then you can give the memory back, and you're good. Okay, that's a traditional profile, and if you look at any benchmarks, you will see pretty much that sort of shape. This does not fit the cloud, because the time it takes you to get to maximum throughput, that is a delay. That means the workload that that service that you're starting up has to do is being done by another one. So you run more services to deal with the fact that one of them is taking time to start up. And also this overpeak. There's a spelling problem, but anyway, it's peak, not peak. The idea is, if you think about it, if you have to buy the next tier in Amazon just to get your application to start, and then you never lose that memory again, that's waste. Okay? We don't want that. We want this. We want applications that start as quickly as possible and have no peaks. In fact, memory and throughput should be as clear together as possible. Okay? Cool. And then there are other things we want. So small memory footprint for sure. We want small deployment because it takes time, might cost you bandwidth, that may cost you money, right? And fast starting applications because they're microservices. And by the way, when my application is idle, I'd like to give back as much as possible of the resource because I don't want to hog it because it costs me money. If I can give it back, that'll be cool. So the question is, can we do this with a JVM? There's a quiz coming on. Quiz. Is cloud so different that the JVM is no longer relevant? So, option A, yes. There's no JVM that could do that we want it to do, so let's move everything to Node. Who goes with that? No?
No takers.
No takers? Oh, it's a foot, it's not a hand. Okay, so no, not A. Okay. B, maybe. Are you sure that retuning the JVM could meet those needs? Do you think some of the characteristics of modern microservices in terms of throughput and profile can be done by just playing with some switches and sliders? Who thinks that we can probably achieve that with the JVM design that we have today? Oh, okay. This is really good. People are responding. Okay.
Well, one person did.
C. No, not all JVMs are the same. The JVM is still relevant, and there is one that can do all that for you. Hey, a sales pitch.
Hands.
Oh, so you're right. Let me go back. Yes, who think... I've just given it away. Forget that. Okay, let's go. Okay, we'll give you a pass on that one. Okay, so September, IBM contributed to Eclipse.
That's last year.
Do you want to do this one?
Just to be specific.
So last year, September last year, 2017, IBM contributed its J9 VM. This is the one that we run our businesses on. This is the one that we run under all the IBM products. It's what all our customers use if they use mainframes and AIX and whatever. Okay, it's the big thing, and we gave it away. We open sourced it. Okay. You can go You can go to adopt OpenJDK, and you can go get downloads of OpenJDK plus Hotspot or OpenJDK plus OpenJ9 on 7, 8, 9, 10, 11, 12, you name it. You can go and get free OpenJDK binaries with a different VM, same VM that IBM uses for its products, same code base. You can go download it. You can go and get Docker images. You can go get this. Hey, we gave it away for you, and you can use it. Why does that matter? Well, it matters because inside this screamingly fast JVM is one of these. Who remembers these? Who had one of these? Yes. It's not a quiz question. Okay. Right. So what's special about Java ME? Okay. So Java ME, running your applications on your phone, what do you want? Small footprint, right? Because you haven't got much memory. Okay. Very limited RAM, maybe some ROM. Okay. Fast startup. Yeah. Because you don't want your game. I start my game. I want it to run before my boss gets here. You know, I want to play the game, not wait for it to start up, right? And I don't want an environment where the game takes time to warm up, please. My analogy, though it's not a phone analogy, is you imagine playing, I don't know, Call of Duty on Xbox or something, and you start it off, and the first thing it is it's all blocky graphics because the GPU hasn't caught up. You know, that's not what you want, okay? You want these characteristics. The important bit is, hey, small footprint improves cost for applications, improves density for providers, if you are providing an environment to run Java in. Fast startup. Immediate ramp up. It's all about gigabytes per hour. They are the same characteristics for ME, okay? So the OpenJ9 gives you these things, right? Because it was initially designed to run on small devices, and it runs on big devices now, right? So what does that give you? How about 30% startup time? Improve, you can see the darker blue is hotspot. There's OpenJ9, same benchmark, no improvements turned on. You turn on the quick starting and the shared classes, and you can get 30% faster startup on your VM, on your application. That's pretty good for cloud. Though, what's even better is without even turning a switch, you can save 50, 60% of your memory consumption. That's pretty good for cloud. So you remember this? Well, here's some real pictures. Here's OpenJDK 9. Okay, it's a bit old, with hotspot. Reasonable benchmark. That's a good line. That's state of the art. Here's OpenJ9. Ooh. Now remember this, the gap between the red line and the blue line, that space, is new work done, more work done. The VM could do more for you in that space. And you can imagine in short-lived microservices, you might not need to go all the way because you can have the response done, okay? There's even an option where you can say, I want even faster startup. This mode is one, just for example, where we've said, how about you do no jitting whatsoever? You do ahead of time compilation, and then you just run it. And after you run it, you spend no CPU cycles on jitting. You just spend your CPU cycles on the application. Well, the throughput in this example has gone down, and we're closing the gap, but that's got down. But you can see, again, there's a now black space between the blue and the green line. More work done. So, this is a VM that started small and grew really big. It's the one that's been going for years and years and years. It's the one that we put under all our businesses, right? If you draw cash out of an ATM, the chances are that somewhere in that stream of computers, there's Java. And if there's Java in the back end, the chances are it's running OpenJ9 or J9, okay? Right? It is something that's been around for years. We open sourced it because we wanted to grow the cloud story.
That one's mine.
Huh? I'm not drinking yours. Excuse me. So, as far as I'm concerned, excuse me, the JVM saves the day. You don't have to take my word for it. Excuse me. You can go research. Pretty much anybody who does the switch should get like 50% savings just out of the box, and playing around maybe you get some more. Go to Adopt, download it, give it a go. If it works, great, let me know. And if it doesn't work, bad, let me know. There's my Twitter handle. So, Cloud Native Java. Are we done then? Yes, nothing to move, nothing to see, move along. Who's happy? Who wants to leave now and just go out, get OpenJ9 and not worry about anything else? Okay. Not really. Still need to re-architect my application. Who thinks that there's more to the story than just getting a better VM? Okay, cool. No, actually, Cloud Native introduces some new challenges. So the subtlety is, do you take your existing application and technologies and just do some carving, or do you actually look at what you need to do, because there's a whole bunch of other things that cloud brings to the table that you need to respond to other than what the VM does? Who thinks there's more to the story than just carving your EE application into little bits? They're hedging the bets.
Yeah.
Cool. I'll hand over to you.
Thank you.
Yeah.
Okay, so Steve's talked about the JVM and the benefits of using OpenJ9 and how that fits with the kind of desirable characteristics of doing cloud-native applications. But the issue can arise that what you run on top of that VM can, if it's some hideously large thing, perhaps badly architected and so on, then it can vastly outweigh the benefits you're going to get from just switching JVMs. So let's look a little bit at application design first, and that will hopefully motivate some of the thoughts on what you do around the runtimes, but also the things that you run on top of the JVM, but also what you do around the applications and how you design and write your applications. So on the left-hand side, we've got a kind of traditional monolithic application. You're probably well familiar with these kinds of things. So you have one application that you deploy. You might deploy maybe 3 instances of it because you've got 2 for high availability and one spare one just in case you put one into maintenance and so on. And organizationally, you have teams that are responsible for components within that application, but also they can commit to other components and things. And this is how you evolve a nice spaghetti monolithic application. And also organizationally, you probably had an architecture team, may still have an architecture team, and they provide kind of architectural oversight over the application and strategy direction, so technology decisions and so on. And finally, the code base is all in one place for your application. And so as we move to microservices, we see a few things happen. One is you're clearly breaking up into a number of individual applications that are going to then collaborate via network calls. But also often a kind of good practice is to organizationally change. So you have teams that are responsible for those microservices, and therefore they're self-contained. Organizationally, you've got modularity, but also at runtime, you've got modularity. So essentially what's going on inside C is not known by the team in B or team in A. So you've broken your application, which might have had 3 instances into 100 microservices, so maybe you're deploying 300 instances of these things, so the cost benefits of using OpenJ9 are going to be important. But what do you do around the runtime choice? So clearly, you're all thinking, I'm going to use Java EE. Okay, so Java EE, you might not think is the right choice to start with. So over the years, Java EE started out small. In the, sadly I remember this time, in the late 90s, evolved over time, adding more and more capabilities. There was a kind of realization around the kind of 2006, 2009 timeframe that this thing was getting too big and too unwieldy, and so therefore needed to be broken up. And so web profile was created, so you could go for web profile or you could go for full platform. And I remember when web profile was being defined, there were lots of discussions about what was going to go into this thing, and it ended up getting bigger and bigger and bigger. But from my experience from talking to customers, they would say, yeah, okay, I like web profile, I'd like to use web profile, but there's always this one thing in full platform that I need to be able to use, so it's actually no use to me. And he carried on evolving, and then even in EE8 we had 6 updates to specifications and 2 new specifications. So EE and the certification process required each vendor to actually provide every capability there and out of the box in order to get the ticky mark. So they were required to produce this monolithic runtime that people certified and used. So what did the vendors do? So this is so I work on OpenLiberty, and this is what we've done, and for balance I also provide another example. It happens to be Red Hat, which has nothing to do with what was announced acquisition-wise. And you can check, because there are recordings of other talks, other examples of this talk where I did have the same Red Hat example. So in Liberty, we have a modular runtime. You start out with a small kernel, and then in your build system you can depend on capabilities that you want in your runtime. So you can essentially build a runtime that's specific, that's tailored to your microservice needs. So in this particular example, we're going to use JAX-RS 2.1 and we're going to use JSON-B. So maybe we're writing a REST service and then exposing it and flowing the payloads using JSON. In the Thorntail Fractions example, so this is built on the Wildfly technology, and it was formerly called Wildfly Swarm. They again have a similar approach where you can depend on what they call fractions in the build. So in this example, we're depending on, again, JAX-RS. And in this example, it's JSON-P that they're going to use for manipulating JSON. I couldn't find a fraction for JSON-B. There may be one. I was on a train with poor connectivity when I was researching this. All right, so we've seen how the actual runtimes that you can use to host your microservices have evolved over time and given you the ability to essentially cherry pick the capabilities you need. So if you're deploying 100 or 200 or 300 instances of these things, you're not paying the whole cost of a full application server for each instance of that microservice. But not all the challenges can be solved just by the runtime or just by the JVM. Because if you're writing lots of microservices and you have teams collaborating, you now have a network involved, you've potentially got latency problems, you've got reliability problems, reliability of the network, reliability of the teams that are providing the microservices that you're depending on. So there are a new set of challenges that you need to deal with. And so this is where Eclipse MicroProfile comes in. So a number of vendors, but also a number of user groups and so on, got together probably about 2 years ago and said, we need to evolve a set of technologies that are going to help people write in an open way, an open collaborative way, cloud-native microservices, because we don't have the APIs that people need. And so that started out as a collaboration at microprofile.io and then eventually moved to Eclipse as an organization. So it's now under the governance of Eclipse as Eclipse MicroProfile. So let's talk about the microprofile technologies, and you'll see how they address the various challenges. So I like to think of MicroProfile as kind of 3 sets of technologies. So the first set are essentially the things you need, the kind of low-level things you need to write, basically write REST services. So I want to write REST services and consume REST services. So producing a REST service. So what MicroProfile did is it said that if there's a perfectly good technology out there in the EE set of specifications, then I'm going to reuse that. There's no need for us to create a completely new specification. So it adopted JAX-RS. So to write a REST service, doing it the MicroProfile way, you use JAX-RS. The next thing you want to be able to do is actually consume a REST service, clearly. And so MicroProfile looked at what was in JAX-RS, and unfortunately in JAX-RS there was a client API, but it wasn't a type-safe API. So MicroProfile defined the MicroProfile REST client, which gives you a nice parallel to the providing service API in JAX-RS. So you essentially use the same annotations to define how you're going to consume the REST service as you do for providing a REST service. So I'm writing my REST services and I'm consuming my REST services, but there's things that go on inside those REST services. So you want to be able to write components, write business logic. And so MicroProfile adopted from the Java EE specifications the snappily entitled Contexts and Dependency Injection specification, or CDI. So anybody here familiar with CDI? Okay, quite a few. That's really good. Normally people look blank at me and I say, think of spring beans. And they go, ah. Okay, so CDI, it lets you write components, write beans. You can then unit test those things because they're using dependency injection for their dependencies, so it's easy to mock the dependencies and so on. But the next thing you want to be able to do, well, okay, I'm writing and consuming a REST service, but I need to say something about the payload and how that's going to be flowed. And so, again, adopting the EE specifications, what MicroProfile did is said, I'm going to let you use JSON-P or the new JSON-B specification, which gives you the kind of Jackson-like behavior. So you just define a bean and it'll do the serialization and deserialization for you. So those are the kind of basic low-layer technologies for producing and consuming REST services. But if we've got hundreds of these things and we're having them collaborate, and we have teams that are evolving those things independently, and you're wanting to put these things rapidly into production, and you're using DevOps and so on, then there's a new set of challenges. So it's not just about can I write a REST service and can I consume a REST service and everything will be fine. You need to cope with the issues that arise from the scale of those number of services and the independent teams. And you also need to deal with the fly crawling across the screen. So this is where we were. So what next? Well, if I've got a team producing a microservice and they want to expose that microservice to another team, they need to document it in some way. So what MicroProfile says is we'll adopt the OpenAPI specification. So are people familiar with OpenAPI? Okay, not so many. No, well, not as many as last question. What about Swagger? Yeah, you usually get more hands for Swagger. So what OpenAPI is essentially a standardization. So SmartBear, I think it was the people that produced Swagger, contributed OpenAPI to, I think it's openapi.org or something like that, and standardized it as OpenAPI. So OpenAPI v3, I think, is the latest one. And so MicroProfile adopted OpenAPI as the description or the definition of those APIs. And what it does is it also defines Java annotations and so on, so you can actually, with your REST service that you've defined, you can actually, if you do nothing, then MicroProfile OpenAPI will generate you, MicroProfile will generate you an API definition from that, and that's fine, you can use that. But you probably want to add some additional documentation, additional information about that API. So OpenAPI defines some additional annotations that you can put onto your REST service description, which means you can have that additional information in the published APIs. Okay, the next thing you need to be able to do, okay, well, you're going to have services talking to each other. You probably want to make sure that they're secure in some way. And so what MicroProfile does here is it says, well, we've got JSON Web Tokens as a way of flaying. We're not going to flay the user. We're going to flow the user information and the role information, in this example, from A to B. And we want to take that user and role information out of the JSON Web Token and then use it to secure our APIs, to define whether the person is allowed to actually call our API or not. And so what MicroProfile JWT does is it says, okay, if I'm going to receive a JSON Web Token with user and role information, you can use the annotations, the Java annotations like @roles_allowed, and say which roles are allowed to call my service API. And then if that user isn't in that role, then they get rejected. Okay, so I've now got an API that's nice and secure, and it's defined in terms of OpenAPI, and it's receiving and producing and consuming JSON potentially. But what if there's a problem with that service? What if when I'm calling from A, that service B is slow at responding, or if it becomes unavailable, or if I overload that thing, then it goes down? I need to be able to deal with those issues and handle those faults. And so MicroProfile defines a specification called fault tolerance, and this defines a number of policies or approaches to dealing with fault tolerance. So you can do things like bulkhead patterns, retry, timeout, and so on, and also fallback. So you can, for example, if ultimately you're not able to reach that destination microservice, maybe you've got some cached information already in your service that you can use and then return back to your caller. Okay, so the next thing that MicroProfile defines is MicroProfile config. So if you're producing lots of microservices and putting those in production, and you're wanting to do rapid continuous integration and continuous delivery or continuous deployment, then the best practice says build that thing once, and as you take it through your pipeline and eventually put it into production, you don't rebuild it. Because if you rebuild it partway through your pipeline, you're effectively invalidating the testing that's gone before, because you might have built it in a slightly different way, and unbeknownst to you, there's some change happened that's changed the behavior. And so the way to achieve that is anything that changes as you go through that pipeline, anything that changes in terms of the environments that you're going to deploy into, so maybe you're going to a different database in a test environment, or a different LDAP registry, or maybe your target services have different locations, or you're exposing your services on different ports, then you want those things to be injected into your microservice through configuration from your environment. And so MicroProfile defines a couple of ways to do that. You can do static configuration injection or dynamically receive configuration. And also it says you can have a number of configuration sources, and those configuration sources can depend on what environment you're deployed into. So ultimately, if you're deploying into a Kubernetes environment, then that can be that configuration can come from a Kubernetes config map. All right, so that's the second layer, all the things that kind of arise from the fact that you have hundreds of collaborating services where you've got independent teams and you're doing DevOps and so on. But what about once you've deployed all those services and you're wanting to monitor those things, understand how well they're doing, understand how to track down problems when things go wrong? And so what MicroProfile does is it defines 3 additional specifications. And so the first of those is MicroProfile Health. So what MicroProfile Health does, excuse me, is let you as the application writer or the microservice writer state what it means for your microservice to be healthy. Because it's only you as the application writer or the microservice writer that knows what healthiness means. So for example, if I have a microservice that depends on 3 other services, one of those services might be incredibly important to me, and the other 2 I might be able to just deal without them. They're kind of additional value if they're available, but if they're not available, then that's fine. I can still function appropriately. So if I want to define what's healthy for my service, I can check the availability of my mandatory service, and if that's available, I can say I'm healthy. But if it's not available, I can say I'm unhealthy. And so through MicroProfile Health, you can define a number of different health checks within your application. There's an endpoint you hit, and then MicroProfile Health aggregates up those tests and returns an overall health statement for your service. And the nice thing it does is it follows essentially the same protocol that Kubernetes liveness and readiness probes do. So, for example, you can point a kube readiness probe at your MicroProfile Health, and it will function appropriately. Next one is metrics. So you might be able to determine, for example, that things are becoming unhealthy. So there's healthiness in terms of the application, but there's maybe healthiness in terms of the runtime. So being able to understand the runtime metrics of what's going on in your microservice is important. So what MicroProfile Metrics does is it lets you, by default, just get a whole load of JVM metrics out, so you can understand things like heap and garbage collection and thread pools and so on. It also allows vendors to add in server metrics, so for example, to understand about server thread pools and things like that. And then lastly, it defines a set of annotations that let you define your own metrics for your application level. So you can do things like measure timing or measure peak load and so on within the operations within your microservice. And finally, the last one is MicroProfile Open Tracing. So you have a number of microservices that are all chained together, and you have requests flowing through those microservices. You need to be able to know where your requests have gone and why in order to potentially determine why things have gone wrong. And so MicroProfile Open Tracing handles that for you. It handles adding the appropriate headers onto your requests so that you can eventually trace the requests through your services. All right, so that's MicroProfile. So just to summarize MicroProfile, it's a set of open specifications at Eclipse. It's got wide vendor support. I think there's about 6 implementations so far. It defines APIs or reuses essentially APIs for REST services. It's got open API support for publishing APIs, security support, fault tolerance, configuration, metrics, health, and open tracing. All right, so we're on to a quiz. So, a team wants to use your service and has asked you to document it. Do you? See it as an opportunity to try out that ASCII doc thing that you heard about at a conference? Any votes for that?
It's cool.
There's a few of them, yeah. I like ASCII doc. Do you suggest they fire a few requests at it? With an infinite number of monkeys, they'll eventually get there. I think this is one of those missing, the simian army. We need the documentation monkey.
This is machine learning, isn't it? Is that it's monkey learning, ML, yeah.
We need the documentation monkey.
Nobody wants that one. Go try again.
All right, so lastly, do you use Open API Java support? Because you essentially get most of the documentation for free, but you can add a little bit of extra through the annotations.
Who goes for C? Yes, no effort.
Great. I think they're going to pass,
Okay.
All right, so next quiz question. You're deploying microservices that depend on other teams' services and have noticed occasional errors from them that cause your service to fail. Do you? Blame the other team every time your service fails. They need to sort their act out. Any votes? Blame always does really well in this talk. In fact, in one session it won. Do you hold firm and trust that they'll fix all the problems eventually, then everything will be fine? Oh, nobody believes that.
No.
Last one. Take responsibility for gracefully coping with instabilities in the services you depend on. Vote.
Oh.
It's about 50-50 for blame.
Yeah.
Which, interestingly, because when we did this at a user group, somebody said, what about ANC? So we do have an ANC option. So I think...
Blame them, but fix your own code.
Yeah.
Yes.
Yeah. All right. So you're about to be the proud owner of a live production microservice. And if, like me, you like your weekends and want to minimize the time spent resolving issues, do you? Decide it's a no-op due to encapsulation. The great thing about microservices is you don't need to know what's going on inside. No, nobody believes that one. Write everything to standard out. Factor 11 of 12 factor tells you that's what you need to do. That's slightly tongue-in-cheek. All right. Do you instrument your service for health and metrics and use open tracing to track request flows?
Yeah.
Yeah. Excellent.
I think there must be another option.
No?
No, yeah. A lot of people didn't put hands up, so there's one missing.
Yeah.
Yeah, okay. Carry on.
We are taking notes.
Yeah.
All right. So being ready for cloud native, just to summarize. So you want to choose a set of open standard-based and with wide open source vendor support technologies. And I think what we're seeing with things like Jakarta, the move of Java E to Jakarta E, and also the establishment of Eclipse MicroProfile, is that the Eclipse Foundation is becoming essentially becoming the center of gravity for those things. You want a JVM that's optimized for the cloud.
Ooh.
Hey, open
I've got one, yes.
Woo. And you want to choose an application framework defined for cloud native microservices, and that's MicroProfile. So, should we do the final quiz or shall I do a demo? We've got 9 minutes.
Who's bored and wants to leave now? Oh, they've all gone.
Don't ask them that.
Okay. Let's do the final quiz. Go on, give them 4 minutes back. They can always ask questions.
All right,
Yeah.
true. So, your boss asks you to recommend an open technology stack for developing. So I hope you were concentrating on the final review. For developing and deploying cloud-native microservice applications, do you recommend Eclipse OpenJ9 to optimize your runtime characteristics and costs for the cloud?
Only my hand counts. Yeah.
Your count. Yeah.
I didn't see very many hands go up. Carry on. B.
Do you recommend Eclipse MicroProfile to add resilience, monitorability, if that's even a word, security and more in a vendor-neutral way?
Wow, tough crowd.
It's all right. There's a better answer coming
Oh,
up.
yeah.
Do you recommend a right-sizable runtime with broad open spec support, e.g. Open Liberty, just to pick a random one, to optimize your deployments for the cloud?
Oh, this candidates for my used T-shirt.
Okay, all of the above.
Yes.
All right. So we've finished the questions.
Go on then. We're now calculating your score.
We're evaluating you. So did you pass? Tension builds. Yay!
Yes.
So congratulations, you are now ready for cloud native Java.
Cool. And we're done.
Thank you.
Thank you very much. What was the last one?
So if you really enjoyed this talk, please rate it. If you didn't, this was DevSecOps by Simon Maple, I think.
Yeah.
Oh, sorry. No, I didn't say that.
Yes, you did. And it's on record. Cool. Thank you very much.
Thanks.
Yeah, right.